Up till this point in the school year, we've been solving equations by a process known as inspection, where we just kind of look at the equation and and say what makes sense as the answer, which I think was an important start to really understand what the solution of an equation is. But starting today, we're going to start using properties of equality to solve equation, which is what I think a lot of you have been taught in the past and what you wanted to apply up till this point. But hopefully you gave inspection a decent effort because it gets into common sense and ways, uh, logical checks of solutions that sometimes we get lost when we use these properties. But at any rate, let's go ahead and get started on that. Lesson 38 today. What does isolate the variable mean? You're going to hear me saying this a lot throughout this video and in the coming weeks while we practice this. What does isolate the variable mean? Here's what it means. It means to manipulate the equation so the variable is alone on one side of the equation. Okay, so we're going to manipulate the equation so that the variable is alone on one side. That's called isolating the variable, getting it by itself. Isolate rather means to be alone. Which operation is the inverse of subtraction? You can see my answer there. It is addition, and vice versa, the same is true. The inverse of addition is subtraction. And which operation is the inverse of multiplication? You might know this already. It is division. And again, this works the opposite way as well, that division is the inverse multiplication, or the inverse of multiplication, and multiplication is the inverse of division. So we're going to use that idea of inverse operations and isolating the variable to solve these equations. So right here, x has 1/2 being added to it. So to isolate the variable, to get rid of that 1/2, we would subtract 1/2 from both sides. And that's what I've done here. I'm subtracting 1/2 from the left side of the equation. Used to just be x plus 1/2. Now it's x plus 1/2 minus 1/2. And I'm also subtracting 1/2 from the right side of the equation. 2/4 is 1/2, and I'm going to need a common denominator anyway. Take special note of that. So then we'll simplify both sides of the equation. I'm sorry, first of all, the directions say to justify my steps, so I'm going to do that. Subtract 1/2 from both sides. Now I'm going to simplify both sides of the equation. Combine like terms. 1/2 minus 1/2 is 0, so x plus 0 is x, and 3/4 minus 2/4 is 1/4. So my answer is 1/4, and all I did was simplify both sides of the equation. So if I'm going to justify that step, that's what I'd write. Let's do some more. X minus 1.3 equals 4.2. So I'm going to add 1.3 to both sides, because the opposite of subtracting 1.3 would be to add 1.3. So I'm adding 1.3 to both sides. Then I'm going to simplify both sides. 4.2 plus 1.3 is 5.5, and likewise on the left side, negative 1.3 plus 1.3 is 0. So you'd have just x left on the left side. Let's keep applying inverse operations to solve equations. Rules of equality. So right here, x is being divided by 4. The inverse operation of division is multiplication. So instead of dividing by 4, I'm going to multiply both sides by 4. See that right here. Multiply by 4, multiply by 4. As long as you do the same thing to both sides of the equation, it's going to stay, it's going to have the same solutions. It's going to be a proportional equation, an equivalent equation, some might say. Okay, 1.2 times 4 is 4.8, and x over 4 times 4 is just x. The 4's cancel out. So, if we make some, oh yeah, and then we've got some symmetry there. Both of these equations are the same thing. That's called the rule of symmetry, or the symmetric property. We should also, use inspection to check your answers. 4.8 divided by 4, is that about 1.2? Yeah, it is. It's exactly 1.2. There's the rule of symmetry shown with some variables. A equals B is the same as B equals A. Three-fifths x equals 1/4. All right, this is a little bit different. People hate fractions, but I actually love them. So I'm going to do the same thing to both sides of the equation, because then I'm not changing the equation at all. And the best way to solve this and get the variable isolated is to multiply both sides by 5/3. Okay, now watch what happens when you multiply both sides by 5/3. Okay, what happens here is that the 3's cancel out over here, the 5's cancel out over here, and all you're left with is x. And on the right, we'll just go ahead and simplify that side. 1 times 5 is 5, and 4 times 3 is 12. So 3/5 of 5/12 is 1/4. Obviously, we need to be able to use this in a real world situation here. Peggy bought 5 pounds of oranges for $4.50. Solve the equation 5x equals 450 to find the price per pound. So they've given us the equation here. 5 oranges at whatever they cost per orange equals $4.50 for all 5 of them. So we'll solve that equation by using inverse operations. What I'm going to do here is divide both sides of the equation by 5. And I'll end up with 0.9. So that means that these oranges cost 90 cents per pound, or 0.9 of a dollar per pound. All right, and let's do that one more time. From 8 a.m. to noon, the temperature rose 5 degrees to 2 degrees Celsius. Solve the equation T plus 5 equals 2 to find the temperature at 8 a.m. So they've given us an equation here where T represents the temperature, and then it increased 5 degrees, so we added 5 to the temperature. T is the temperature at 8 a.m. We added 5 degrees to that, and it ended up being 2 degrees Celsius at noon. All right, so the original temperature we could solve by, or find by, subtracting 5 degrees from both sides of this equation. And we've learned how to add integers already, or subtract integers. So we know that 2 minus 5 is -3. So our answer is at noon, or sorry, at 8 a.m. the temperature was -3 degrees Celsius. Okay, so I know a lot of you have been dying to be able to solve equations not by inspection, but by using these properties of equality. So give it a shot here over the coming lessons, and we'll get better and better at it. See you soon.